Our next topic is factoring difference of two squares. The best way to teach this is by giving an example, but before that, I would like to describe it first to you. Difference of two squares is something that looks like this, where this is a perfect square and the second term is also a perfect square. And according to this one, it says difference, so therefore this won't work. This type of factoring is not going to work if this is an addition. It has to be a minus or a subtraction. So how does difference of two squares go? So what you're going to do is so the factors of this are, you're going to do two parentheses. Since that is a negative, you will have to put 1 plus 1 minus. And it's always like that. It does not matter if your minus is here, your plus is here, for as long as one is plus, one is minus. And you're going to get the square root of each of these. The square root of 4 is 2. So you'll have a 2 there and a 2 there. The square root of x squared is x and x. And the square root of 49 is 7 and 7. And that's it. Those are the factors of 4x squared minus 49. Okay, example number 2 is 25x to the fourth minus 16x squared. Well, first of all, this is a binomial, so I think it's going to work. This is a subtraction. I'm looking at the first term and I'm seeing that this is a perfect square, including the variable. That's a perfect square. And you would know it's a perfect square if this is an even number. And this is also a perfect square. Therefore, we can use the difference of two squares factoring, which is make two parentheses like this. One is plus, one is minus. This time I'm doing this, minus and plus right here. As I said, it won't matter where you put it for as long as one is plus, one is minus. The square root of 25 is a 5. I'm going to put a 5 there and a 5 here. The square root of x to the fourth is x squared. You'll just have to divide it by 2. That's the rule for the variable. And 16 has a square root of 4. And y to the second power divide by 2. The 2 divided by 2 will have to be a 1. So you'll just split it into half. Therefore, these are the factors of 25x to the fourth minus 16x squared. For our third example, I have 24x to the third minus 54x. I'm looking at this and I'm seeing a binomial and I'm seeing that this is a difference. However, this is not a perfect square and this is not a perfect square. But that is actually, it will become a perfect square if you do common monomial factor first. So you really have to look at your terms and see if you can factor it out first by common monomial factor, then do the other ways of factoring. I know that 24 is the greatest common factor of 24 and 54 is 6. So I can take out 6 right here. And, oh, between x to the third and x, greatest common factor is x. So I'm taking out 6x on both sides. If I divide 24x to the third by 6x, it's going to give me 4 to the second power. I'm sorry, 4x to the second power. I need to erase that. Okay, now it's fixed. 4x squared is what I meant. And then copy the minus sign. And 54 divided by 6 is a 9. And x divided by x is a 1. So that's it. This is it already. However, the big question is, are we done? If you look at the factor inside, you are with a binomial that is also difference of two squares. These are perfect squares right here. So therefore, we are not finished. This can actually be factored out. Okay. So I have two factors for this one. And it can be one is plus, one is minus, because that's a minus. Square root of 4x squared is 2x. So 2x on both sides. And square root of 9 is a 3. And once again, this will have to be carried over down here. So we have three factors. One is 6x, the other is 2x plus 3, and the other is 2x minus 3. This is the completed factored form of this expression. Okay, example number 4 is 9x squared minus 1. This is a difference of two squares because that's a perfect square, and that is, as you all know, is 1 times 1 is 1. So that has a square root of 1. So we can go ahead and do the plus and minus. And then square root of 9x squared is 3x. So 3x on both sides. Square root of 1 is 1 and 1. And the only thing that you will have to do now is to examine this because that has a minus. Can this be square rooted? Can that be, is this a perfect square? This is a perfect square, but this is not. So therefore, this is already your final set of factors. Okay, example number 5. 81x to the fourth minus 1. Well, first of all, I know that this is difference, and so I'm going to examine, is that a perfect square? The answer is yes. Is this a perfect square? The answer is yes. Therefore, I can do this. 1 is plus, 1 is minus, and again, it won't matter where you put it. And so square root of 81x to the fourth is 9x squared. Again, square root the 81, which is a 9, and then divide the 4 by 2. So this is also a 9x squared. This is square root of 1 is a 1 and a 1. This cannot anymore be factored out, but I'm looking at this and I'm seeing that there's still a minus, and that is still a perfect square, and this is still a perfect square. Therefore, I can still further go and do this. Okay, and so 1 is plus again, 1 is minus, and the square root of 9x squared is 3x, and this is 3x. Square root of 1 is 1 and 1 again. Therefore, guys, the final, oh, well, I'm going to copy that down. So, 9x squared plus 1. The final set of factors for 81x to the fourth minus 1 are all these. These are your factors. My sixth example is 25x squared plus 16y squared. Well, first of all, I intentionally gave this because there was a question that was raised a while ago, which was, what happens if it's a plus? Well, first of all, if it's a plus, as you can see in the title, it says factoring difference of two squares. Guys, difference. This cannot work if it is an addition right here. Therefore, I'm looking at this. Is there any common factor between 25x squared and positive 16y squared? And the answer is yes, there is, but it's 1. And 1 won't matter. Therefore, this is already a factored form. You cannot factor that any further. I want you to look closely. And my seventh example is 25x squared minus 16y squared. Exactly the same as my sixth example, but this time there is a minus sign. Because there's a minus sign and this is a perfect square and that's a perfect square, I can do what the rule says, which is break it into two parentheses. One is plus, one is minus. Won't matter which one it is that you're choosing. This can be your minus, that can be your plus. Get the square root of 25, that's a 5. Get the square root of x squared, that's an x. Put it here as well. Get the square root of 16y squared, which is 4y. And 4y. This cannot be factored out any further. I'm going to look at this and examine, is that a perfect square? Because if it is, then I can still further factor it out. In this case, it's not. This is also not. Therefore, these are the factors of 25x squared minus 16y squared.